Hi everyone, we're going to continue with learning how to solve trig equations. Section 7.5 has equations that are a little bit more complicated, so we'll be seeing some tricks that we need to do in order to get them to work. Some of these tricks will be using some of those identities that we've seen in the previous sections. So let's get started. And I'm just going to jump through some examples and see how they go. I'm going to start with one. Oh, I don't know. We'll see how. Yeah, let's just jump right in. Oops, cosine. Okay, so I have 4 cosine of x, sine of x, plus 3 cosine of x equal to 0. If I look at these, I have 2 terms. It's already set equal to 0. I'm going to factor out that cosine, and I'm left with 4 sine of x plus 3 equal to 0. So here is my cosine of x equal to 0, or my 4 sine of x plus 3 is equal to 0. If I'm solving where the cosine is equal to 0, that is going to be when x is pi over 2, and again at 3 pi over 2, but we can combine these by adding on that pi k if we wanted to go multiple times around. Solving this one, I get that the sine of x, so I subtract the 3, divide by 4. Sine is negative in the third and the fourth. So negative 3, 4, negative 3, 4. This is not my 3, 4, 5. It would be 16 minus 9. So it is not one of those triangles I know. So I would have to do an inverse sine to come up with my value. If I do that, and if I stay in my radian mode, inverse sine of a negative 3/4, I come up with x being a negative 0.848, rounded to 3 decimals, and then adding on my 2 pi k. Now that takes care of this one. To put this one in there, we're going to actually take pi and add that. So pi plus my 0.848, plus pi, and I get 3.990 plus my 2 pi k. If I round to 3 decimals. If I wanted to go more decimals, it's actually 3.98965. So depending on where we want to round is where we would go on that one. Okay, let's continue on to another one. 1 plus sine of theta is equal to 2 cosine squared theta. And for these, let's just find the solutions for 0 less than or equal to theta, strictly less than 2 pi. So in just one time around the circle. Now on this one, we'll notice that we have both sines and cosines involved, and so it's also a squared, so it kind of looks like a quadratic, but I have a sine instead of the cosine. So there my quadratic is a little bit thrown off. But what I'm going to do is I'm going to substitute this cosine squared and turn it into something else. And that's where our Pythagorean identity comes from. So remember, we know that cosine squared plus sine squared, that's our Pythagorean. So cosine squared is 1 minus our sine squared. So I'm going to substitute this in for that cosine squared so that everything is then in terms of sine. And now I have a kind of a quadratic in terms of sign. I'm going to make sure to solve a quadratic we need a 0. So I'm going to distribute this first. Distribute that 2. And then get everything on one side. So I'm going to move these guys over. So 2 sine squared plus my sine minus 1 is equal to 0. So that 1 minus the 2 gave me that minus 1. If I wanted to do a u substitution, I get 2u squared plus u minus 1 is equal to 0. Okay, so trying to factor this, I'm looking for two numbers that multiply together to give me a negative 2 that add together to give me a 1. Negative 2 that add together to give me a 1. Believe that will work. So rewriting that u as a 2u minus u. So I'm going to factor out my 2u, u plus 1, factor out my minus 1, u plus 1 equal to 0 times 2u minus 1 equals 0. I'm going to go over here. U is equal to negative 1, or u is equal to 1/2. So we have that the sine of u is equal to negative 1, or the sine of u is equal to 1/2. And some of you know these already because you've been working with them over and over and over again. That is fine. The sine of u being a negative 1 means that our hypotenuse and the opposite side are the same. Or I always think of my sine curve. You know, where is it negative 1? It's down here, which means that is my 3 pi over 2. And since I'm only looking between 0 and 2 pi, that is my only solution. Sine being 1/2, sine is positive in the first and the second, so 1/2. And this is my 1/2 square root of 3, which means u, that's my 30, which is pi over 6, and the 30 in that would be my 5 pi over 6. So I have three solutions, the 3 pi over 2, the pi over 6, and the 5 pi over 6. If I wanted all my solutions, so I didn't have this piece here, I would add on those 2 pi k parts. Let's do another one. The sine of 2 theta minus the cosine of theta is equal to 0. Okay, so again I have sines and cosines. I also notice that my angles aren't quite the same. So I might want to first of all get those angles to be the same. And to do that, I'm going to use my double angle for my sine function. So going to my formula sheet, I'm going to pull off that double angle formula. So sine of 2 theta is 2 sine theta cosine theta minus the cosine of theta equal to 0. So I did a substitution using one of my identities from the sheet. Now I'm in terms of just thetas. I'll also notice these both have a cosine in them. So I can factor that out. Cosine of theta, and I'm left with 2 sine theta minus 1 equal to 0. I can set each factor equal to 0. Solving this, so adding 1, dividing by 2, I get that 1/2. You will see the 1/2s a lot because that is one of the triangles we like, that 30, 60, 90. The zeros and the negative ones are also ones that you will see a lot. So here, theta is going to be where the cosine is 0, which is at pi over 2. And again, 3 pi over 2. if I am going between, again, we'll stick with that, just that one time around. Sine is positive in that first and that second, 1/2, square root of 3, negative square root of 3. So here we have that theta is my 30, which is pi over 6. And the 30 in that second quadrant, 5 pi over 6. Now if I wanted all of my solutions, add on a 2 pi k, add on a 2 pi k. These two are pi apart, so I could take this one and add a pi k. All right, let's do one more example in this video. Let's go with sine squared theta equal to 2 cosine theta plus 2. Now we've seen this trick already in the first example of this video, and we have the sine squared and the cosine, so it's kind of like a quadratic, but not quite. So the first thing I'm going to do is change the sine squared to 1 minus cosine squared. Again, that comes from our Pythagorean identity, and we're solving it for sine squared. So sine squared is 1 minus cosine squared. I'm going to get everything on one side. I prefer my squared term to be positive. And then subtracting the 1, I get 1. Here I can do that u substitution again as the cosine of theta. So this becomes u squared plus 2u plus 1. This one I should be able to factor by itself. I think it's u plus 1, or u plus 1 squared, which means u is equal to -1. Put in the equal 0 in here, which means cosine of theta is equal to -1. And the cosine of theta equals -1 when theta is at pi. Okay, I always think of my cosine curve. Here's my cosine curve. Down here, that's right halfway there, so that's at pi. If this was one time around where my solutions, if this was what I was looking for, I would be done. If I wanted all my solutions, I would add on that 2 pi k to go round and around and around and around and around. So depending on my directions will determine how I write my answers. Okay, I'm going to stop the video now and do another one so that we can kind of break them up into small chunks. And I'll see you in the next video.